Here we go again. We are polynomial practice test. We're on number 16, the difference quotient. Now this is a review from our functions unit. This will be on your final. You do need to remember how to do this. Okay, so for number 16, we're going to do the difference quotient. Now remember, it is 3 steps. It is 3 steps. So the first step is to do the f of x plus h. Then you subtract the original function. And then you divide everything by h. So don't forget how to do this one. And the actual problem we're going to do is, took me a minute to find it, is f of x is equal to x squared minus 5x plus 5. So my first step, I'm going to do f of x plus h, which means replace both of the x's with the x plus h and simplify. So that's going to be x plus h squared minus 5 times x plus h plus 5. So I'm going to square this. It's going to be, I got to do my FOIL, x squared plus xh plus xh plus h squared, which is x squared plus 2xh plus h squared. Distribute the negative 5 and the 5. That is all step 1. Now we're going to go into step 2, which is to subtract the original function. So when I subtract the original function, it's going to be a minus x squared, a plus 5x, and a minus 5. And what's going to happen is some fun canceling. And all I'm left with is 2x squared, xh, plus h squared minus 5h. So now I'm going to do step 3. Step 3 says divide by h. So I'm going to divide everything by h. And we're going to get 2x plus h minus 5. And that's the difference quotient. You will see this on the final. I don't know if it'll be on your test, but it will definitely be on the final, so make sure you review it. Okay, number 16. Number 17, domain. So now we did both of these problems back in the function section when we talked about domain of a fraction function and domain of a radical function. And so we have rules for these. Now technically we're going to rehash the domain for this first one, but all you have to do is set the denominator equal to 0 and solve. And technically, since the denominator can't be equal to 0, we throw out that number. So x plus 9 can't equal 0. So x technically can't be negative 9. So when I do my number line, negative 9 is excluded. So my domain is going to be negative infinity up to negative 9. Skip over the negative 9. And then go to positive infinity. There's my domain for the first one. Okay, now for the second one is a radical. The radical had a different rule. The rule for radicals is to set the inside greater than or equal to 0 and solve. So I'm going to do x minus 14 greater than or equal to 0. Add 14 to both sides. And I get x must be greater than or equal to 14. So my number line, equal to 14, greater than 14. So there's my number line. And then my answer is going to be a bracket because it says equals in infinity. So there's my domain for number 18. Okay? All right. Those 3 problems were reviewed from the functions test. All right, so now let's jump back into the polynomials and rationals. So now we're getting into the rationals. The rationals are the fraction functions. We did the domain just 2 seconds ago. And now we're going to do what we call the vertical asymptotes or the wholes. And they are very much related. Very much related. So to find the vertical asymptotes or wholes, we set the denominator equal to 0 and solve, and then we make a decision. So I'm going to do x minus 6 equals 0, x equals 6. Now, this is either a vertical asymptote or a whole. And how do we make the decision? Wholes have a matching factor in the numerator. So if it's a whole, it's got a match in the numerator. These do not match. Do not match. No wholes. There is no match. Therefore, this is a vertical asymptote. So I have a vertical asymptote at x equal 6. All right? Let's look at number 20. Do we have a match in the numerator? No. No matching. No match, so no wholes. Okay, so we're going to take each factor, set them equal to 0. So actually in the denominator, I have 2. I have x equals 0, and I have x plus 5 equals 0. So I have 2 vertical asymptotes. That is possible. I have 2 vertical asymptotes at x equals 0 and x equal negative 5. Next. All right, let's see what we got next. Okay, this one, same thing. We're looking for matches. Now, technically, this needs to be factored. If you can factor, it needs to be factored. So this is going to factor into x minus 2, x plus 2. I may have forgotten that. The bottom is, of course, x minus 2. So now look, we have a whole. We have a match. This means a whole. So x minus 2 equals 0. X equal 2 is a whole. Now, no vertical asymptote. Why? Because there's no more things in the denominator. Vertical asymptotes come from the denominator. So once we did the x minus 2 and determined it was a whole, nothing else left. So there's no vertical asymptote at all. All right, this one, same thing. We're going to factor this numerator. And exactly the same thing. We have a match. This is a match. So this is going to be a whole. X plus 11 equals 0. Subtract 11 on both sides. X equals negative 11 is a whole. No vertical asymptotes. Why? Because there's no more denominator. No vertical asymptotes, there's no denominator. All right. Next concept is a different one. It's the horizontal asymptotes. You've got 3 basic rules. You need to memorize these rules. The first one is big on top. Let's do them in the different order. Big on bottom. Same. And then big on top. If it's big on bottom, y equals 0 is my answer. If it's the same, we're going to do y equals a over a. If it's big on bottom, it's none. And what we're talking about here is the degrees. Back to the degrees. All right, let's check out the degrees here. For this first one, the degree on top is 1, and the degree on bottom is 2. This one's big on bottom. So the horizontal asymptote is at y equals 0. And yes, you have to type in y equals 0. All right, second one, the degrees are the same. So the 36 and the 9 are the a's, the first number, in my polynomial problems. So we're going to have a horizontal asymptote at y equal 36 over 9, which is, of course, 4. So that's that one. 25, again, we have horizontal asymptotes. We have same degree. So we have a horizontal asymptote at the numbers. Horizontal asymptote at y equal negative 4 over 5. Okay. Next up is the oblique asymptotes. We will do those on the next video. And we have some multiple choice in there as well. Okay, it's just math, y'all. Keep doing it.